Hello, Ibrahim. Ibrahim, are you there? I cannot hear you. Ibrahim, can you turn on your camera? What are you doing? Sleeping? Hello.
Hello, teacher.
Hi, Raul. How are you?
I'm fine, thank you.
So, did you celebrate today International Women's Day at home?
Yes, I know.
Yes or no?
Yes, I know.
Did you buy flower for your sisters or mother?
Yes,
What did you buy?
only rose.
Only rose. How many?
And I don't know.
And?
I think there are 11. 11.
I see. Did you also buy chocolates?
Yes, of course.
Good. Raul, can you turn on your camera? There's nobody here, so you don't have to be shy today. Let me see your
What?
face. Can you turn on your camera?
Okay, 1 minute.
Today we are going to have class together with you, I think. Ladies are absent. I don't know. And Ibrahim, I think, sleeping. Good.
Yeah.
Raul, where do you study?
In the Baku Europolice.
Baku is international school or?
Yes.
Okay. How is your math at school?
Very good.
Very good. Okay, very good. So if it's very good, I'm going to ask one question, Raul. Okay, ready?
Yes.
Okay, there's one simple question. Okay, it's about logic. Let's see if you can get the right answer or not. Can you read the question first?
Okay. Two women and Carol and two men, Bob and David, are athletes. One is a swimmer and second is skater, third is a gymnast and fourth is a tennis player. On a day they were seated around the square table. The swimmer sat on Anne's left, the gymnast sat across from Bob. Carol and David sat next to each other. Uh, a woman sat on the skater's left. Who is a tennis player?
Okay, Raul, did you understand the question? Here we are talking about four people, and it's, I say that two women. You should actually pay attention to every word here. Anne and Carol, they are women. And Bob and David, they are men, right? And
I think
huh?
I think the tennis player is near of the I don't know, gymnast.
Okay. So who is a tennis player? Who is a tennis player?
He's a David.
Davids. No, that's wrong. You need to think one more time. Okay. So we are talking about a square table. Let's say they are sitting on a square table. That is a square table. Okay. So let me just start with you. Okay. Then let's see. You can continue. A swimmer sat on Anne's left. So suppose that Anne is sitting here. Okay. So where is Anne's left? Anne's left is here, right? So swimmer is sitting here. Okay. Right. Now, David, Raul, think a little bit. Okay, I give you 2 minutes. Okay, now read the second one. The gymnast sat across from Bob. What do you think? Where is Bob sitting? Here. Carol and David sat next to each other. A woman sat on the skater's left. So using this for information, we have already used A actually. Okay. What do you think? Who is a tennis player among these guys? You need to draw a square on a piece of paper and N is sitting there. Let's say swimmer is there and continue. What do you think? Let's say if you can get the correct answer or not. Tissue. Any answer, Raul?
No answer.
Let me just write here. This one is top, this one is bottom, and left and right, as you see in the screen. Okay, now we are done with the first statement, right? The swimmer sat on Anne's left. Okay, Anne is somewhere here. Swimmer is there. The next question. The gymnast sat across from Bob. What do you think? Where is Bob sitting? Can Bob sit here, for example? Raul, can Bob sit here? Yes or no?
Yes.
Why yes? Raul, why yes?
Teacher, my internet don't very good, and sometimes I can't hear your questions.
I see. Okay then, but do you hear me well?
Don't very well.
Okay, here, all right, let's continue then. It says the gymnast sat across from Bob. So Bob cannot sit here. Why? Because if Bob is sitting here, opposite Bob, who is sitting, gymnast is sitting, right? So Bob cannot sit at the bottom. So we have two possible answers. Bob is sitting either here or he's sitting either here. Because from this information, we have two possibilities. Now, all right. Now we are done with the second statement, right? And the gymnast sat across from Bob. If Bob is sitting at the top, then gymnast should be sitting here. Okay. If sitting on the right, then gymnast must be here. Okay. So I'm not sure yet. And in C, it says that Carol and David sat next to each other. So that means that if Bob is sitting here, Carol must be sitting at the top and David must be sitting at the bottom. So that means in the C, it says that Carol and David sat next to each other. That's why this Bob cannot sit here. So that's why I'm deleting here. This Bob must be sitting at the top. If Bob is sitting at the top, then now I'm sure that gymnast is sitting opposite, right opposite to Bob. So gymnast is here. Let me write in red. So gymnast is here. Okay. So now A and B. Now we know their positions 100% correctly, right? So now we will continue. Carol and David sat next to each other. So that means that either Carol is here, David is here. Or maybe David is here, Carol is here, right? One of these. Okay. So now we'll continue. D, a woman sits on the skater's left. Okay, so we know that this gymnast is here, right? If David is sitting here, right? Actually, C must be skater. So on the left, actually women. So David is not women, so David cannot sit here. So which means that David must be here. So if David is here, Carol must be here. Carol is a lady, right? So now it says that a woman sat on the skater's left, which means that David is skater. So if Bob is swimmer, C is Carol is gymnast, and D is skater, only one sport is left here. What is it? Tennis player. So that means that Anne must be tennis player. So the answer is Anne is a tennis player. Okay, Raul, did you understand?
Yes.
Good. Raul, can you read the next question?
How many digits are there before 58 of the following number?
Okay, how many digits are there before the 58th of the following number? Okay, to solve this question again, we need to actually see the pattern, right? Otherwise, we cannot solve this.
Teacher,
Now
I
here
don't
we,
know the question.
what do you say?
I don't know this question. I don't know answer of this question.
But actually, did you understand the question?
Don't worry. Well,
Here it says that how many digits are there before the 58th of the following number? Okay, so as you see here, number one, the first 8 is here, right? Here I have 8, and after the 5, and I have 8 again, 2, 5, and I have 8 here, 3, 5, and 8 here, 4, 5, 8 here, 5, 5, right? Each time, actually, the number of 5 is increasing. So that means that here, okay, here 50th 8, right? From the after the first 8 we have 1 5, right? And here we like this, I can just write 8 and 5. The second 8, here we have 55, and third 8, and here we have 5 5 5, and continue here, right? This one is first 8, this one is second 8, this one is third 8. After the first 8 we have 1 5, after the second 8 we have 2 5, after the third 8 we have 3 5. What is the question? Before the 50th 8, if you continue here, if we have 50th 8, right? 50th 8, after that, how many 5s do we have here? 55. Actually, we have here 50, right? And how about before this? It says because it says before the 50th 8, before the 50th 8, I have here, let's say 49th 8. If we have 8, so I have here 49. 5, 5 dot 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 5. How many fives here? We have 49. Okay. So before the 55, I need to count this. Okay. So now 1, 2, 3, 4 until 49. So that means that I have 49 eighths. So here we have 49 eighths. 49 eighths, right? And the plus, how about here? In the first row, we have 1 5. In the second row, 2 5. In the third row, 3, right? Until 49. So that means that in the first one, how many fives do we have? Now I'm going to count this. So in the first line, we have 1. In the second line, we have 2 fives. In the third one, 3, dot, dot, until 49. Here we have 49 5. And what is it? It's just the sum of the first 49 natural numbers. And here I'm just going to use this formula. We know that S is equal to 1 plus 2 plus 3 plus M. What is it? The first n natural numbers. I think we got the formula with you before. It is just equal to n times the next natural number, n plus 1 over 2. That gives us the sum of the first n natural numbers. And also here we have 1 plus 2 plus 3 plus until 49, the first 49 natural numbers. So the sum is equal to 49, and next natural number is 50 over 2, which is equal to 50, actually, what is it? Okay, 50 over 2, that is 49 over 49. Okay. We have 25. 50 over 2 is 25, and 25 is multiplied by 49. That's equal to 1, 2, 2, 5, right? We now have to multiply. It's 25, just 49. 25 times 50. Anyway, 50 times 50 is equal to 2,500, and divide by 2 and subtract this. Anyway, just multiplying two two-digit numbers, 1, 2, 2, 5. So that means that before 58, we have 1,225 fives. And also here we have 49 eights. So altogether, how many digits? Because in the question they are asking how many digits. Altogether, we have 1, 2, 2, 5. Fives plus 49. Eights altogether 1,260. It is 74 digits. Before 50th, what is it? 50th, 8. The answer is 1274. Okay, Raul, did you understand a little bit?
Well, yes.
Good. All right. Raul, read the next question.
Teacher, I have a question.
Yes.
Why our group friends don't in this need another not in this lesson?
Raul, I think today is International Ladies' Day, right? Women's Day.
Yes.
Maybe girls are celebrating the
But
it.
where Tariel then?
Huh?
But Tariel isn't girl. Why? Where is he?
Who?
Tariel.
Huh? Tariel. Tariel. About Tariel, I have no idea why he's absent.
And I have no idea.
Is he your classmate? No.
Yeah, no. But I know him, and his school is near of my house.
Oh, I see. But you do not study at the same school, right?
No.
Hmm. I see. I don't know about Tariel. Maybe he is sick, or maybe he's busy. I have no
Or
idea.
or he's celebrating 8 March with his mother.
Yeah, maybe. Okay. All right. Here, last time, if you remember, actually we saw questions, but at the
Teacher, but
time,
where then Ibrahim?
Ibrahim, he is here, but he doesn't answer. Maybe he is busy or sleeping or tired. I don't know. Okay, but usually Ibrahim does not participate in the class. He just joined the class, and I don't know even why he's here. Maybe
I don't know why, but only me in the class today,
today,
I
Raul,
think.
it's only you, Raul. It's only you. Okay. So why
Okay.
are you tired or bored or
Find
what?
the total number. Uh-huh.
Huh?
Find the total number of triangles in the diagram.
Okay. That's also a bit tricky question. Okay, there are a lot of triangles, and for example, if you count from here, for example, let me just name this. Let's say this one is A, this one is B, and this one is C, and this
There are 40.
40.
Yes.
How did you count it?
Very easy.
How? Tell me.
Can I show each in the blackboard?
But just tell me, how did you count it? Okay, did you count one
Let
by
me
one
check.
or use some
This is
different method?
one. This is two. Oh, this is three. And it's everything four. In this type, there are a lot of these.
So like
Um,
this, you count one by one and you got 40?
yes.
I see. So
Oh, sorry, not 40. 14.
14. Okay. I think counting it is, I don't know, it's just systematic way we need to count this. Now, number one, if I start from here, for example, containing this dot, for example, how many triangles do we have? Okay, so that is one triangle, right? And really actually explaining it may be a little bit hard. I don't know how to do this. Like, for example, let's say this one, right? This triangle, it is one, and this one, it is two, and this one, it is three. Okay. Raul, if you just look at this dot, for example, how many triangles can you see that actually contains this dot? Maybe it is A, B, E, one triangle, A, B, F, another triangle, right? And A, B, C, another triangle. So that is three already, right? Containing only the dots, okay? So that is one is A, B, E. Actually, I already use E here, F. I think I should use here G. Okay, so number one is ABG, one, okay, plus, let me just count first and after I'll write this. ABG, one, ABF, another one, ABC, another one. Here we have three, plus ABE, right? It is another one, and any other triangle? No. So we have one. So that's equal to 4. Okay. So now I just actually delete this. Now, how about containing, let's say this dots. Uh, okay. I think I will just count from here, from using A, for example, ABG, right? One. ABF, another one. ABC, another one. It is 3. ABE, another one. It is 4. And any other triangle? No. So here we have 4. Okay, A is gone. Now I cannot use any more because I just counted all the triangles that actually contains the vertex A. How about using B? Now I have actually using B, BGF1, BGC, it is 2, BFC, it is 3, BEF, it is 4, BEC, it is 5, BDC, it is 6. So containing A, it is 4, containing B, it is 6. Okay, and also we are done with this. How about G? GFE, it is one. GEC, it is another one. Do we have any other? No. So containing G, we have two. Okay, we are done with this. Okay. How about F? FEC, it is one. FDC, it is two. Containing F, it is two. FED, FDC. That's it. And the FED, FDC, and also FEC. We have one more. It is three. For G, GEF, GEC. That's it. Okay. So now how about containing E? It is EDC 1, right? Only one. Containing E, it is only one. So now altogether, 4 plus 6, 10. 10 plus 2, 12. 12 plus 3, 15. 15 plus 1, it is, we got 16 here. Raul, what do you think?
Nothing.
I mean, does it make sense? Actually, I need to just start with one vertex. Use this one and try to find all the rectangles that contains vertex A. And that is only 4. And after that, I delete this because we counted already all the triangles that contains A. And after that, vertex B. Now I delete vertex A. All the triangles that contains vertex B. We count this after the vertex C and D and E. In this way, systematic way, if you count this, we don't get confused. And maybe in your free time, you need to draw this and try. If you find more than 16 triangles, let me know. Okay, let's see another question. Raul, read the question. At least you don't feel bored much if you read the problem. Raul, can you read question 18?
Yes. Teacher has a bag of sweets to treat her class. If save, if she gave 5 sweets to each student, then she would have 13 sweets left. If she gave 8 sweets to each student, then she's then 1 minute. Then she would have 20 sweets short. How many students and how many sweets are there?
Okay, good. Ibrahim, are you here? Ibrahim.
Yes.
Why are you so quiet, Ibrahim?
No, I am always here.
Are you busy now?
No, but
What are you
my
doing?
internet is bad. Nothing.
Okay, good, Ibrahim. At least read the problem for us so that you will get participate in the class in this way. So a teacher has a bag of sweets to treat her class. Okay, now the question is how many sweets he has? We don't know. Let's say he has n sweets. Okay, if she gave 5 sweets to each student, then she would have 13 sweets left, right? If she gave 8 sweets to each student, then she would have 20 sweets short. That means that 20 sweets more will be needed actually to give every student 8 sweets equally. And how many students and how many sweets are there? Okay, so in the school, suppose that in this class we have X students, okay, or let's say not X, let me write here M students. And how many students? Suppose that we have n suites. I have already used it at the beginning, right? And we are distributing these suites to the students, right? So in the first one, the suites, right? And if we give 5 suites to each student, we have m students. Each student gets 5 suites, right? We have m students, and she would have 13 suites left. I mean, the left means the remainder. Still, we have 13 suites. And it says that if she gave 8 sweets to each student. So again, we have n sweets that it does not change. How about if we gave 8 sweets to each student? So here we have 8 and we have m students and 20 sweets short. She would have 20 sweets short. That means that we need more sweets to give 8 sweets to each student. Okay, that is our question. All right. So that's how we should you should be able to write this in this form, okay? Because here still we have 13, that's the remainder. And 20 short means still we need 20 more so that each student can get 8 sweets. So now how do we solve this? Now on the left hand side we have m, and in the first one n equals something, and the second one n equals something. That means that this 5m plus 13 should be equal to 8m minus 20. Now from here, if you take this 5m to the right hand side, I have 8m minus 5m. And take 20 to the left hand side, that is 13 plus 20. Now 8m minus 5m, that's equal to 3m. And here we have, what is it? It is 33. So 3 times what number is 33? M is equal to 33 over 3. That's equal to 11. So now if m equals 11, we can get the value of n using the first or second equation. So what is n? N equals 5 times m, that is 11, plus 13, which is equal to 55. That's equal to 68. So in the class, we have how many students? We have 11 students. And how many students? We have 60, how many sweets in the bag? And the teacher had 68 sweets in her bag. Okay, Raul Ibrahim, that's how we solve this problem. And also last time we did similar question, I guess. Okay, that's not so hard. Just we need to understand the problem. That is the biggest thing here. Once you understand the problem, I think solving is much, much easier. Another question, find the value of this. Okay. Uh, I think it should be piece of cake for you. One more time we will do this, okay? Using telescopic method. Here we have in the denominator, what do we see here? 1 times 2, 2 times 3, 3 times 4, blah, 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 and 2 times 13 times 2014. Let me denote this sum by S, okay? We need to find this S. And again, I'm just going to use very simple formula here. What is it? That is, if you're given like fraction, and in the denominator we have the product of two positive consecutive positive integers. What is this? For example, this one is m, that is m plus 1, right? For example, if m equals 1, that is 1 times 2. If m equals 2, that is 2 times 3. If n equals 3, that is 3 times 4. If m equals 2013, for example, what we have here, that is 2013 times 2014. So now actually I can just write it as 1 over m minus 1 over m plus 1. Why is it so? Because if you simplify the right hand side, I will get the left hand side. For example, let's say, let me just write here, for example, 1 over m minus 1 over m plus 1. How do you simplify this? We need to bring into the common denominator. The first fraction's numerator and denominator multiplied by m plus 1. 1 times m plus 1, that is m plus 1. And multiply the denominator by m plus 1. So here we have m times m plus 1. Minus the second one multiplied by m. 1 times m is m. And the denominator we have m times m plus 1. Now we have the same denominators, right? We have common denominator. We should just draw a single fraction line and write the common denominator here and subtract the numerators. Here we have m plus 1 minus m. And m, they cancel out each other. That's equal to 1 over m times m plus 1. Okay? That is a proof of this formula. And since now we have proved here, that means that I can use it to solve this problem. So now here, we need to find S, so that S is equal to, according to this formula, what is it? 1 over 1, 1 over 1 times 2. I can write the first fraction as 1 minus 1 over 2. Plus the second one, 1 over 2 times 3. That is 1 over 2 minus 1 over 3. Plus Next one is 1 over 3 minus 1 over 4. Plus it continues. And the last one is 1 over 2013 minus 1 over 2014, which is equal to, Ibrahim, what do you think? What is next? Can you see the numbers but with opposite signs? Ibrahim Iskandar, are you there? Okay. Anyway, Raul, if you are there, as you see here, negative, right? 1 over 2 plus positive 1 over 2. That's equal to 0. Minus 1 over 3 plus 1 over 3. That's equal to 0. Minus 1 over 4. After this, we have 1 over 4. That's equal to 0. And before this, we have minus 1 over 2013. Also, the year sum is 0. That is 0, 0, 0, 0. Now, what is left here? Only one, it doesn't have a pair, and also the last fraction, it doesn't have a pair. So here we have 1 minus 1 over 2014, which is equal to, just we need to simplify this, right? 1 is 2014 over 2014 minus 1 over 2014 equals, here we have 2014, 2014 minus 1, that's equal to 2013. So that means that that fraction, I mean, this sum is equal to 2013 over 2014. Rahul, any questions?
No question.
Good. Rahul, can you read the question?
Yes. She has 23 coins. She divides them into 5 piles so that each pile has a different number of coins. Find the smallest possible number of coins in the biggest pile.
Pile. Okay. Pile. Susie has 23 coins. She divides them into 5 piles. Let's say this one is pile A, this one is pile B, and this one is pile C, and pile D, and pile E. Okay. And it says that 5 piles so that each pile has a different number of coins. And that's why pile A contains the most number of coins. That's greater than B. And pile B contains also the second most, and pile C and pile D. Okay. So actually pile A contains the most number of, what is it, coins. Now in this question, it says that if it is so, find the smallest possible number of coins in the biggest pile. Okay. So that means that for A to be the smallest, and also E must be the smallest. The smallest means actually, what is it? E must be maybe the biggest. Okay. For example, let's say if this one is, we have 25. So if this one, let's say we have 5, then here also we have 5 and 5 and 5. This A contains only 3, but which is not possible, right? For A to have the least number of coins, right, as the biggest file, this E, it must contain the maximum possible number of, what is it, coins. So that's not possible. Also, actually, this A, B, C, D, E, they cannot be equal to each other. So what do I do here? From here now, I get 1 and put it in pile A. At that time, I have here 4, and here we have 5, and here we have 5, and here we have 5, here we have 4. But still, these 3 are equal, right? And how about again, if I take 1 from the second one and put into the pile A? So I have here 5, here I have 5, 5, and 4, and 4. Still not actually the same. How about if I just take 1 more from here and put into file A? So I have here 6, here we have 5, here we have 4, and 4, and 4, right? So now if I pick 1 from and put in pile A, so here I have 7, here we have 5, and here we have 4, and here we have 4, here we have 3, right? And to make them same, how about if I just pick one from this and put in file A, it will be 6. Okay, let me just one more time. Here 6 and 4, it is 3. Here we have 3, right? So how can I change this? I need to actually pick one, right? Put into here. At the time, it will be, here we have 7, it will be 6, this one will be 5. Okay, not from this, maybe from the first one. From the first one, so at the time, here we have 3, here we will have 2. I just pick one and put into this. So now every pile contains different number of coins. The first pile is 2, the second one is 3, third one is 5, and the next one is 6, and the biggest one contains 7. So find the smallest possible number of coins in the biggest pile. It is 7. It cannot contain less than 7. If it is 6, it should be 5. If it is 5, it should be 4. And this, for example, if it is 6, right, it should be 5. 5, it should be 4. 4, it should be 3. This should be 3 and 2. Then your sum will not be 23. So only it is 7, that is 7. Then it is 6, it is 5, and 3, 2. Okay, so the answer is dot, dot, dot. It is 7. Okay. Let's do one more, maybe 2 more questions after that. Okay. We will finish the class. Find the next term of the following sequence. Okay. Here we have 1, 4, 9, 7, 7, 9, 4, 1. And again, 9, 1. Okay. So actually, if you just try to say any pattern, 1, 4, 9, 7, 7, 9, 4, 1, and 9, 1, what do we see here? Actually here, 1, 4, 9, 7, and 7, 9, 4, 1. They are symmetric, right? If you just take these numbers, they are symmetric. 4 numbers and 4 numbers. How about here, 9? Actually, it is 9. Again, 1, 9, 1, 9, 1, and okay. So if it is 9, 1, 9, 1, next one will be 4. It should be 4. Find the next term of the following sequence. The first 8 numbers. 1, 4, 9, 7, 7, 9, 4, 1, and 9, 1. Okay. All right. I think what we see here is this 1, 4, 9, 7, 7, 9, 4, 1. They are symmetric. Also, to find this 9, on the left it is 1, on the right it is 1. And after that, before this 9, here we have 4, and also the next digit must be 4. So the next digit is, next number is 4. Given that 5 factorial means 5 times 4 times 3 times 2 times 1, right? So usually we call this factorial. This means that it is, how we read this, factorial. What does factorial means? Actually in math, n factorial means the product of the first n natural numbers. Okay, until n. The question is, find the last 2 digits of 2014 factorial. So we know that actually if you write 2014 factorial, now if you just write here 1 times 2 times 3 times dot dot, and here for example I have 10 dot dot, I have for example 100 dot dot, I have even 1000 dot dot, and here we have the last number is 2014. Now if you multiply this many numbers, and we have a lot of powers of 10, right? Like we have 10 or 20 or 30 or 100 or 1000, not only 2 digits. Actually, a lot of the last digits will be zeros. And that's why the last 2 digits of this number, it will be, what is it? 0 and 0. Okay. Raul, that's the last question. Okay. And 2 more questions. And after that, we will finish the class. There were 210 students in the hall. Okay, 202 students all in the hall. Let's say here we have solution. And 2/5 of the boys and 1/3 of the girls were teachers. Okay. If there were 78 students in the hall who were teachers, how many boys were in the hall? So now here we have some boys and girls. Let's talk about who are wearing t-shirts. And here we have boys and here we have girls and who are wearing t-shirts. 2/5 of the boys wearing t-shirts and 1/3 of the girls wear t-shirts. So that means that how many boys do we have? Suppose that here we have n boys. And how many girls then? Altogether we have 210 students. So that is 210 minus n girls. And 2/5 of the boys, 2/5 of boys, and 1/3 of the girls. Girls 210 minus n. They are wearing t-shirts. If there were 78 students in the hall who wore t-shirts, that is 78. The question is how many boys were there in the hall? That means that we need to find n. Now from here we have 2n over 5 plus this one is 210 minus n over 3. That is equal to 78. And let's multiply both sides by 15. If you multiply both sides by 15, here we have 15 times 1 over 5, it is 3. 3 times 2, it is 6n. Plus 15 times 1 over 3 is 5. So here we have 5 times 210 minus n. On the right-hand side, I have 78 times 15. Okay, now if you remove the brackets, 6n plus 5 times 210, that is 1050 minus 5n equals, what is 78 times 15? 78 times 15 is 1170, 1170. And 6n minus 5n, that's equal to n, 1170 minus 1050, which is equal to 120. So in the whole, how many boys? 120 boys. And the last question, Raul, that's very interesting question. This one, a farmer wants to plant 10 trees in 5 rows, such that there are exactly 4 trees in each row. Draw a diagram to show how the trees should be planted. And actually, at the first glance, you may think that that's not possible, but one beautiful way is, how about if you just plant your trees in a star shape? Okay, something like this. So now we have 10 trees, right? 5 rows. That is the first row, it contains 1, 2, 3, 4. The second row, 1, 2, 3, 4. Third row, 1, 2, 3, 4. And the last one, here we have, actually here we have 5 rows. Each one, if you look at this, it contains, what is it? 4 trees. Altogether, how many trees we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The only way to do this is if we plant them in star shape. Okay. Raul, thank you very much for your patience and attention. Okay, have a good night. I will meet you on Thursday. Okay, enjoy your day.
Okay,
Okay, bye-bye.
goodbye.